On this 6.7 power stroke, P0300 means the PCM may be seeing a random or multiple cylinder misfire pattern. The driver may feel a rough idle, a shake under load, reduced power, or an intermittent miss that only shows up under certain operating conditions. Broadly, this can involve fuel delivery, injector operation, cylinder sealing, air handling, EGR or boost control, sensor feedback, or a wiring and connector issue. Before clearing anything, save the captured operating conditions. If regeneration starts during testing, let it finish before judging the data, because the values may be biased. Also use care around energized injector wiring. Relieve fuel pressure before opening the fuel system. Keep ignition sources and personal electronics away from fuel work. Handle spills correctly, and clean fuel residue before returning the engine to operation. Start with the basic system checks. Then confirm whether P0300 is present by itself or with other misfire codes. Do not get pulled into the wrong path. If P0300 or a cylinder-specific misfire code is active, continue into the misfire diagnosis. If the code is not present now, use the captured operating conditions in the customer's complaint to try to reproduce the symptom. The vehicle may need to be driven to make the miss show up. If you cannot recreate it, stop there for now and treat it as an unable to duplicate concern rather than guessing. Next, look for other stored codes that are not part of the misfire group. If another non-misfire code is present, diagnose that first. The same applies if any other code is present outside the misfire group. The idea is simple. Do not diagnose P0300 until you know another fault is not driving the misfire symptom. Once P0300 is the code you are actually chasing, check low-pressure fuel delivery. With the ignition on, monitor FLP pressure, command the fuel pump on and then off, and remember that the pump runs for 30 seconds then shuts off with ignition on and engine off. FLP needs to be greater than 379 kPa or 55 psi. If it is not, leave the misfire path and diagnose the low-pressure fuel system. If low-pressure fuel passes, run a relative compression test. If all cylinders pass, move to the power balance test. If relative compression does not pass, go straight to a cylinder compression test on the suspect cylinder. On the power balance test, if all cylinders are contributing correctly, the path moves into the broader air, fuel, and sensor checks. If a cylinder is weak, stay focused on that cylinder and test only that injector first. For a weak cylinder, disconnect the suspect injector connector and measure resistance on the component side between pin 1 and pin 2 at the applicable injector connector. The expected range is 150,000 ohms to 210,000 ohms. If the injector resistance is outside that range, move into the dedicated injector electrical diagnosis. If it is in range, carry out a cylinder compression test on that suspect cylinder. If a mechanical concern is found, repair it as needed, clear the PCM codes, and repeat the self-test. If compression checks out, disconnect all injector electrical connectors. Remove the glow plug from the suspect cylinder, crank the engine, and watch the glow plug hole for fuel mist. If fuel mist comes out, install a new fuel injector, clear the PCM codes, and repeat the self-test. If there is no fuel mist, move into the broader air and fuel diagnostic path. When the misfire path sends you into the broader air and fuel side, start by checking EGR position feedback against the commanded position. For the Superduty values shown in this path, the EGR position sensor is checked against approximate table values such as 0.92 volts to 1.07 volts at 0% and 3.14 volts to 3.23 volts at 65%. If the feedback does not approximately match, diagnose the EGR system. If it does match, move to the MAF signal. With the commanded air devices brought to the test state, record the MAF high and low values, set the graph limits 0.2 Gs per second or kilohertz above and below those recorded values. Then lightly tap the MAF IAT sensor and wiggle the harness from the sensor to the PCM. If the signal breaks out of that range, diagnose the MAF system. If it stays stable, check MAF flow at idle and at 2000 RPM. For this Superduty path, the idle range is 30 to 36.8 Gs per second, and the 2000 RPM range is 116 to 125 Gs per second. If MAF is outside range, stay with the MAF diagnosis. If it passes, inspect for engine control modifications, intake restrictions or leaks, crankcase ventilation issues, CAC leaks or restrictions, low CAC coolant level, exhaust leaks, restrictions, loose connections, punctures, cracks, or non-factory changes. If a concern is found, repair it, clear the PCM codes, and repeat the self-test. If the visual inspection does not find the problem, smoke test the exhaust and intake systems. Keep the pressure controlled. Pressure above 241 kPa, 35 psi, can damage components, and shop air is regulated to 137.9 kPa, 20 psi, before connecting. The exhaust system is pressurized with 139 kPa, 20 psi, regulated shop air, and the intake air system is pressurized with 137.9 kPa, 20 psi, regulated shop air. If you find a leak, restriction, or damaged component, repair or install a new component as needed. Clear the PCM codes, road test the vehicle safely, accelerate enough to achieve full boost, and repeat the self-test. If no concern is found and the return point in the test flow is not clear, pause, recheck the earlier diagnostic path, and avoid guessing. The air management checks also verify that pressure sensors agree and that the turbo system responds when commanded. With ignition on, MAP should be within 9.5 kPa, 1.38 psi of baro. If it is not, diagnose the sensor that is out of range. When commanding VGT duty cycle up and down at 1,500 RPM with the EGR and throttle commands at the test state, MAP pressure should increase and decrease with the command. At normal operating temperature, another boost check compares MAP to baro at 0% VGT command, and then looks for MAP to increase by greater than 48.26 kPa, 7.0 psi, at 100% VGT command. If MAP does not respond correctly, diagnose the turbocharger system. The path also checks EBP and MAP-A against baro. EBP should be within 7.5 kPa, 1.09 psi, and MAP-A should be within 5 kPa, 0.73 psi of baro. If either is out of range, diagnose the sensor that is out of range. Then command VGT again at 1,500 RPM and confirm both EBP and MAP rise and fall with the command. A later warm test uses EOT greater than 70C, 158F, compares MAP to baro at 0% VGT command, and then looks for a boost increase greater than 36 kPa, 5.20 psi for pickup vehicles, or 48 kPa, 6.96 psi for all others at 100% VGT command. After the air and boost checks pass, warm the exhaust temperature side of the test and compare the oxygen sensor percentage values at idle. The exhaust temperature condition is greater than 200 degrees Celsius, 392 degrees Fahrenheit for 2 minutes, and the two oxygen percentage PIDs should be within 2% of each other at idle. If they are not within 2%, install a new nitrogen oxide sensor module 12 and carry out the scan tool reset and clear function for nitrogen oxide sensor 2. If they match, check low pressure fuel again. Command the fuel pump on and off, and confirm FLP is greater than 379 kPa, 55 psi. If it is not, diagnose the low pressure fuel system. If it passes, carry out the sufficient clean fuel test. If that test finds a concern, repair as needed, clear the PCM codes, and repeat the self-test. If clean fuel and low pressure fuel are not the issue, run relative compression again. If all cylinders do not pass, move into the engine mechanical path. If they pass, check fuel balance quantity at idle with the engine at operating temperature. In drive, the balance spec separates transit connect at within 2.4 milligrams, 0.04 grams. For this Super Duty, use the all others value within 3.2 milligrams, 0.05 grams of each other. Then run the power balance test at normal idle, with ECT at least 158 degrees Fahrenheit, 70 Celsius. All cylinders should contribute within 10 RPM. If available, run the manual injector balance test under the same type of warmed-up idle condition, and again look for all cylinders within 10 RPM. If either balance test fails, move into the cylinder or injector diagnostic path. If balance passes, key off for a minimum of 15 seconds so rail pressure can bleed down. Then monitor FRP. The FRP PID should be between 0 kPa, 0 psi, and 3,447 kPa. Next, start the engine. Raise engine speed to 1400 RPM, command FRP DSD to 180 millipascal, 26,106 psi, then down to 40 millipascal, 5,801 psi, and confirm FRP voltage increases and decreases with the command. If voltage does not follow the command, diagnose the fuel pump control system. If it does, carry out the high-pressure fuel system test. If that test finds a concern, move back into the fuel system diagnostic path. If it does not, the system may be operating correctly at that time, and the concern may have been caused by a loose or corroded connector. If the path points toward the PCM side, disconnect all PCM connectors, inspect for pushed-out pins and corrosion, reconnect them, and make sure they seat correctly. Then verify whether the concern is still present. If it is still present after that connector check, install a new powertrain control module, complete the required programming process, clear the codes, and repeat the self-test. If the concern is gone, the system is operating correctly at this time, and the fault may have been a loose or corroded connector. Keep verification separate from testing. After any repair, clear the PCM codes, repeat the self-test, and when the path calls for it, road test the truck safely and confirm P030 stays gone. Bottom line, do not treat P030 as a single part failure. Prove fuel supply, cylinder health, injector behavior, air handling, sensor feedback, and connector integrity in order. For more diagnostic training, visit stepdiagnostics.com.